Welcome to Coast Revision Session 1. There's 2 sessions in total. The first one will be coastal processes and landforms, and the second one will concentrate on management of coasts. Just a few things to remember. This is 50% of your final grade, so you must make sure that you revise thoroughly. These keynote presentations do not cover every single detail that you need to revise, so make sure that you have your revision guide and your notes to hand to make sure that you can look through any details that you need to. There's 3 sections to your exam. You need to answer 1 question from each section, so you'll be answering 3 questions in total. And please don't worry if you haven't done the case studies that are on these keynote presentations. Use your own case studies that you've studied if you wish. So there's 2 key questions that you need to think about. What geomorphic processes take place at the coastline? If you think back to your coursework, you'll probably recall quite a few of those instantly. And how and why are distinctive landforms created at the coast? So before we tackle the question of geomorphic processes, we need to understand how waves are formed. Now we all know that waves are created by wind dragging along the surface of the sea. So the stronger the wind is, and the longer it blows for, and the longer the fetch, means larger waves. Okay, so hopefully we all know that the fetch is the distance that the wind has to blow over. So as the waves break on the shore, we need to think about what type of waves that they are. So are they constructive, are they destructive? If you see on the diagram, you've got an arrow pointing towards the beach where the sea runs up the beach, that's the swash, and as the sea pulls back down the beach, that's the backwash. So swash is water rushing up the beach and backwash is water rolling down the beach. If your swash is greater than the backwash, you have a constructive wave. Okay, so the material is carried onto the land and the backwash is not pulling it back out again. So you've got land being formed. If your backwash is greater than your swash, then you've got destructive waves. So you're pulling more material back off the beach than you are depositing. So the piece of land is getting smaller. So what geomorphic processes take place at the coastline? Well, we're going to cover 4 things today. So these processes are weathering, erosion, transportation and deposition. You need to make sure that you know all of these key terms and the detail that goes with each one. Don't forget that a geomorphic process is the physical and chemical interactions between the Earth's surface and the natural forces acted upon it to produce landforms. So to start us off then, weathering. Weathering is the breakdown of the Earth's rock through direct contact with the atmosphere. It can be physical, chemical or biological. So if you look underneath, we've got an example of each. Number 1, physical weathering. So freeze thaw, this is where water gets into natural flaws in rocks, like cracks. And in very cold weather it freezes and it expands slightly. As it cools down, it melts so it contracts, then it'll expand again. As it expands, it cracks little pieces off the rock, breaks little pieces down, and it starts to crumble. Over time, if this happens over and over again, it crumbles away quite a lot. The next one down then, chemical weathering. Sometimes the rain from maybe gas emissions or industry and things, it can get mixed in with lots of chemicals in the air. Some of it's natural as well, and as the rain hits different stones, different rocks on the ground, it's slightly acidic. Usually it's weak carbonic acid, and it just starts to wear away the face of rocks. Okay, so you can see on the picture where I've put a picture of a face of a rock being worn away. And finally, biological weathering is just where the roots of plants start to interfere with the rocks and break them away so that they've got more room. Okay, the second geomorphic process then is erosion. So erosion is the removal of rock through ice, wind, sea or river. So underneath this process you've got other smaller processes that you need to know. So attrition, abrasion, hydraulic action and corrosion. Attrition is where 2 rocks or 2 pebbles are carried by waves and they bump into each other and break each other down. This is how pebbles get nice and round. Okay, attrition, that's the one we've just done. Abrasion is the process by which the coast is worn down by material carried by the waves. So the waves throw the particles against the rock and break it down. Hydraulic action is a process where water gets trapped in those little flaws in the coastline again, and it pushes the air and the water inside the little cracks, and the cracks are forced open, just loosening the rocks and widening the cracks. And corrosion is the chemical action of the seawater. The acids in the salt water slowly dissolve the rocks. It's very much like chemical weathering, but in the waves. The third geomorphic process is transportation. So we're talking now about all the things that have been eroded and weathered away, the material that's come off your cliffs and your rocks. They're transported. So traction, if we start right at the really large pieces, where really big boulders and rocks are pushed along by the force of the water, so they can only be carried a very small distance because they're too big. Saltation is where smaller stones are bounced along the seabed. They go a little bit further because they're a little bit smaller. A suspension is where very small grains of sand and silt are carried along with the water, so they get carried a little bit further because they're even smaller again. And a solution is where some material is dissolved completely and it is carried, so that's carried the furthest. So you can see the diagram at the bottom, an example of each of those. How is material transported along the beach then? So when we think about our different processes underneath, you've got your traction, etc. We think mainly at the coastline of it being moved by a process called longshore drift. Now, longshore drift is created by, firstly by the direction of the wind. So it follows the direction of the prevailing wind. The backwash is always at right angles to the beach. As you can see on the diagram, the arrows pointing downwards where the waves will come down the beach are always at right angles. Okay, so your swash is the direction that's moving your particles down the beach. So if you were to draw an arrow to show the movement in the direction of longshore drift, you can see at the top direction of movement, it would be going from left to right. So waves follow the direction of the prevailing winds, the backwash is at right angles, and the movement of sediment along the coastline follows this longshore drift. Finally, deposition happens when the water slows down. The water hasn't got enough energy to carry the material any further, so deposits it. If the swash is more powerful, the backwash, then you get deposition at the coastline as well. So looking at the geology of coastlines, what the coastline is made from plays a very big part in how the geomorphic process shapes the land. So if you have a look at the first diagram here, you can see stripes of like a green and yellow rock. Okay, the yellow is supposed to represent soft rocks and the green is supposed to represent hard rocks. If you look at the second diagram, you can see over time the waves have bashed against both of these types of rocks and eventually have worn away both of those types, but they've worn away the soft rock much more rapidly than they have the hard rock. So you can see headlands and bays have started to form. So the yellow areas are where the bays would have formed and the green areas are the headlands. So soft rock is prone to weathering and that creates the bay, and the hard rock is resistant to weathering erosion and that's your headland. So now on to the second question. How are Maya distinctive landforms created at the coast? So there are two types of coastline. You have your destructive coastlines and your constructive coastlines, so it depends what type of waves you get at each one. Okay, so your destructive coastline, so this is where erosion happens a lot, so erosional landforms. So just to start with, this is your very basic destructive landform, your wave-cut platform with your wave-cut notches. So the waves attack the base of a cliff through the process of abrasion, corrosion, hydraulic action and attrition. And over time the cliff will be undercut So you've got a wave cut notch right at the bottom where that little arrow is. And obviously the cliff above it can't support itself, it becomes very unstable and falls down, collapses. Okay, over time you get a platform that develops along the bottom where lots of pieces of cliff have fallen into the river and been deposited on the beach. Okay, erosional landforms then, apart from your wave cut platform and your wave cut notch, and other destructive features that you can get. So I've labelled them all on the diagram. You can see it starts right at the left hand side with a crack. So this is just a weakness in the rock, and hydraulic action and abrasion play a massive part, and they widen these cracks and open them up into the next stage, which is caves. If you just have a look further along, and a cave are just cracks that are further eroded to form large voids. Again, if this cave even further erodes and continues to erode from both sides, it can develop into an arch, which is your next formation along. Erosion from both sides in the headland leave a hole where the rock has collapsed and that short arch in the middle. Once again, if we carry on with this process, if that continues to erode, the top of the arch will get very weak and eventually collapse. So if you move on again to a stack is an arch that becomes unstable, unable to support itself, and the rock falls away, leaving a stack. Okay, this is what we think of when we think of Old Harry and Old Harry's wife now. That's a stack, Old Harry, and Old Harry's wife is a stump if you have a look a little bit further along. So a stump is just a stack that's eventually worn away to leave a stump. Okay, finally, depositional landforms. We can think of the Holderness coast when we think of a depositional landform. If we think of the spit at Holderness. Okay, so my first depositional landform on my constructive coastline is a beach. So this is one we've probably all been to. It's formed by constructive waves depositing material that have been transported from elsewhere, so sand and shingle. So there's two different types of beaches, sand beaches and shingle beaches. If you've ever been to a sand beach, lovely flat, wide beaches, they're flat and they're very wide because the sediment that's carried in the waves can be deposited only when the waves are very, very slowed down. A shingle beach is very steep and narrow because shingle can't be carried very far. It's bigger than sand, so it's deposited very easily. Spits are the next type of landform. So if we think again of the Holderness coastline, there's a spit on the Holderness coastline called Spurn Head. It's formed by longshore drift. The material is deposited where the coastline bends. So again, if we think of the Holderness coastline, where the Holderness coastline meets the River Humber, that's a change in the coastline. Where this change happens, there's two areas where the water slightly slows down, so there's lots of deposition that happens there. Eventually all this sand is deposited and the spit over time becomes bigger and bigger and slightly curves because of the direction of the wind. The area behind can become mudflat or salt marsh over time. Bars, the material is deposited between two headlands and a lagoon can form behind the bar. Okay. A tombolo is a bar that connects an island, often a stack, to the shore. Finally, the case study. This might not be the case study you've used. Like I've said before, you can use your own case study if you wish to do so. This case study is actually in the GCSE Geography OCR Specification B Revision Guide if you want to have a look at it. So if we have a look at the map to your left, you can see a full map of England, the UK. If you have a look right down to the south coast, you can see the red line that goes down to the Dorset coastline. And it's enlarged for you. So we go all the way from Chesil Beach all the way to Swanage, as you can see on your map. So I've just labelled on there, you've got Durdle Door where there's an arch, Lulworth Cove where there's a bay, Chesil Beach where there's a tombolo, Swanage and